Hi, I'm Chinesh, and today we're going to do determinants. So every square matrix can be associated with a real number called its determinant. So a square matrix is a matrix whose number of rows is equal to the number of columns it has. So this is a 2 by 2 matrix, so that's true in this case. So we can find the determinant of this. You can write out the way you write out a determinant of a matrix. So let's say this is a matrix A, so this is A, B, C, D. So to write a determinant of A, you just write DET of A, which is equal to DET of the matrix itself, A, B, C, and D. So, or another way to write it out is writing it with absolute value signs. A determinant of A is equal to, instead of the brackets you normally have for these matrices, you now use absolute values when you're trying to say you're trying to find the determinant of this matrix. So A, B, C, D. So always remember, if you have absolute value signs on a matrix, you're trying to find its determinant. So let's start with 2 by 2 determinants. Now this method only works for 2 by 2 matrices, so it only works for 2 by 2 matrices. Only 2 by 2 matrix. So let's start with this is matrix A, and we're trying to find the determinant of A. So I honestly prefer the absolute value method. Either way, it kind of works. I feel absolute value, this absolute value sign, it just makes it easier than writing out DET. So determinant of A of matrix A, B, C, and D, it's actually pretty simple. What you do is you multiply this diagonal, the main diagonal of the matrix, that is subtracted from this other diagonal. So what I mean is, like, you multiply A times D and you subtract B times C. So it's as simple as that. Finding the determinant of a 2 by 2 is as simple as just multiplying the diagonals and subtracting them from one another. So now let's do an example. So let's say we define matrix B as 2, 5, 3, 4. This bracket looks bad. Let's change this real quick. That's a little better. Okay. So the determinant of B is the determinant of this, which is 2, 5, 3, 4. And to do this, it's as simple as just multiplying the diagonals. 2 times 4 minus 3 times 5. So 2 times 4 minus 3 times 5, which is 2 times 4 is 8, minus 15, which will give you negative 7. So determinants will always give you a single value that's used to, will represent this matrix. Before I go on and to tell you how to do the determinants of matrices higher dimensions of 2 by 2s, so like 3 by 3 and onwards, let's first learn the pattern for the matrix of cofactors. The name doesn't really matter, matrix of cofactors. So, you have to know this to actually find the determinant and inverses of matrices. So I'm gonna have to teach it to you right now. So it's simple, right? This is just a pattern on how to make any matrix a matrix of cofactors. So basically, you have a plus, minus, plus, minus. It goes on depending on what the dimensions of the matrix you're trying to change into a matrix of cofactors. So if you need a matrix, a 2 by 2 matrix, it'll be plus, minus, minus, plus. That's all you need, 2 by 2. But 3 by 3 is just plus, minus, plus, minus, plus, minus, plus, minus, plus. So it's just basically alternating. A good way to think of it is you're just technically trying to multiply with positive 1 or negative 1, depending if it's plus or minus 1. And I'll tell you when to use this so that it'll make sense. But for now, just remember that when you're trying to use the pattern for a matrix of cofactors, it's like multiplying with either positive one or -1. Um, and that's for each term of the matrices. So it'll make more sense once I show you. But for now, just remember this. I'll come back to it later. All right, we have matrix A, and we're trying to find the determinant of A. So previously, our method for finding the determinants only worked for 2 by 2 matrices, but as you can see here, this is a 3 by 3 matrix. So we have to use a different method to do it. This method could be annoying at times, but it's just a lot of arithmetic. You have to be patient when doing anything with matrices anyway. So let's start. So determinant of A, let's write it out as determinant form. So it'll be 5, -9, 4, 4, 2, 1, 0, 1, 1. All right. Before we go any further, we gotta choose one row or one column, either one. All right. One row that or one column that's easiest to use. I think the best one is this one because it contains a 0, and the other two values are 1 and 1. I'll show you why it's easier than the other ones to manipulate and to find the determinant of. So let's choose that. Now, if you remember from last time, I had the pattern for matrix of cofactors. Now it's going to apply to this. So let's try to find the pattern for matrix of cofactors for a 3 by 3 matrix. If you remember that, it was basically just plus, then you go to minus, plus, then it's minus, plus, minus, plus, minus, plus. It's as simple as that. It just keeps alternating. Now, this, you gotta apply the matrix of cofactors only to the row that we chose, or the row or column. In this case, it was a row, so we're gonna apply this onto our row that we selected. So remember when I said you treat them as multiplying with +1 or -1 depending on what the sign is? Yeah, this is what we do right now. So we just basically we take the values out 0, 1, 1, and apply this plus, negative, plus. You don't have to write this out. This is just to explain. So +0 doesn't matter. Positive or -0 is just 0 anyway. There'll be -1, and this will be +1. We're essentially just multiplying by +1, a -1, and a +1, just to get these values. This is how we applied the pattern for a matrix of cofactors, just to get this row out like this. Now the reason we did this is because let's start with 0 right now, so that we basically cancel all the row and column that involve 0. If you do that, then you're left with this matrix. This value is in the matrix, which is -9, 4, 2, and 1. We take that and start with 0. We multiply by the determinant of -9, 4, 2, and 1. And that's the first that's the first term. Let's do -1. We add -1 times, and we got to do the same thing we did with 0. 1 minute. We choose the value 1 and get rid of the rows and columns that involve 1, and then we're left with a few values. We find the determinant of 5 of the values that remain. That means 5, 4, 4, 1 in the order that's presented. So we start with 5, that's the first value. The next one here is a 4, which goes in here. And then there's another 4 over here, which goes here. Then we have the 1. Oh, the 1 that goes here. Find the determinant of that. Then we add the next one, which is 1 times. Do the same thing we did with the 0 and the 1 previously. And cancel all the row and column that involves it. And we're left with a few values that we find the determinant of. So that's 5, negative 9, 4, and 2. Now, if you solve this out, you should be able to get the determinant of this. So let's quickly solve it out. So remember when I said the determinant of a matrix will always be a real number? So since 0 is being multiplied with the determinant of this matrix, that's basically multiplying with a real number. 0 times any number is 0. So we don't even need to find the determinant of this. This will be 0. Then we got to do the next one, plus negative 1. And what this is, remember this, we got to multiply by the diagonal, subtracting from the other diagonal. So it's 5 times 1 minus 4 times 4. All right. Let's do the next one. 1 times anything is itself, so we're just gonna get rid of the 1 because it's not needed. So we do 5 times 2, and subtract it from 4 times negative 9. Subtract it from 4 times negative 9. So 0 plus anything is the value itself, so we can just ignore the 0. So 5 times negative 1 is 5, minus 4 times 4, which is 16, times negative 1. So the 5 minus 16 is negative 11, times negative 1 would be 11. And then we gotta add 5 times 2 minus 4 times negative 9. 5 times 2 is 10. 4 times negative 9, and then 5, which will be 46 here. If we add them together, we get the determinant as 57. Let's try to find the determinant of a 3 by 3, but with a different method. So this method only works with 3 by 3 matrices. So don't try it on any other method. So let's say we have this is the same problem from before, but let's do it with this method. So what we do first is we take the first two columns and we write it out here. All right. Let's start with the first column. We write out 5, 4, 0. The second column, negative 9, 2, and 1. Negative 9, 2, and 1. And what we do is you start by multiplying the first diagonal. This is the first diagonal, 5, 2, and 1. So let's do that. It'll be 5 times 2 times 1. And then we add the next diagonal, which would be negative 9, 1, 0 times 0. So that'll be negative, add negative 1. Negative 9 times 1 times 0. And then we add the next one, which is the last diagonal, 4 times 4 times 1. So we add 4 times 4 times 1. Now we do it, now we subtract this entire thing from the diagonal that goes this way, 4 times 2 times 0. So we subtract 4 times 2 times 0 plus the next diagonal, 5 times 1 times 1. 5 times 1 times 1. And then we add the last one, which is negative 9 times 4 times 1. Negative 9 times 4 times 1. I'm running out of space right here. Yeah, I used up too much space in the first bracket. But this should give you the determinant of this 3 by 3 matrix. So let's solve it out. That's 5 times 2 times 1 is 10. Negative 9 times 1 times 0 is 0. 0. And then 4 times 4 times 1 is 16. Then we subtract this entire thing from 4 times 2 times 0, which is 0. 5 times 1 times 1, which is 5. And then plus negative 9 times 4 times 1, which ends up being negative 36, so plus negative 36. Then we solve this out. it hopefully should get us 57, which was the determinant of this matrix that we solved from the previous problem. So let's solve it out again. So 10 plus 16 is 26. Here we have 5 plus negative 36, which is negative 31. So it'll be plus 31, and this ends up being 57. Both methods work well. This is my preferred method on doing 3 by 3, find the determinants of 3 by 3 matrices. Now let's try a 4 by 4 matrix. So we cannot use the shortcuts that for the 2 by 2 and 3 by 3 on this one, so we gotta do the long method, I guess. Let's choose a row or column that makes it easier to find the determinant with. So I think we should choose this one here, because this one contains more zeros than any other row or column anywhere. That we gotta apply the matrix of cofactors, the pattern for the matrix of cofactors onto this row specifically. So let's pull that out. So the pattern would be starting with plus, it goes to minus, plus, minus. It stops there because already 4 is gone. We already have 4 of them, so we go for minus, plus, minus, plus. It keeps alternating with the signs, just remember that. And this is our 4 by 4 for the pattern. And since we chose this row, we gotta correlate it with this row on the pattern for the matrix of cofactors. So this one here. So we gotta apply this row onto this row. So it's essentially just like, you see this negative 2 here, we gotta apply the negative onto that. So it's basically negative 2 times negative 1, which is 2. 0 doesn't matter, but if you were to solve it out, it'll be 0 times positive 1, which is still 0, I guess. Yeah. And then we got 6 and then negative sign, so we do 6 times negative 1, which is negative 6. The other one is 0, again, doesn't matter, I guess still 0. So let's do that. Let's take the 2. And to get this determinant, you remember what I said last time, you gotta cancel the row and the column that involves this negative 2. This negative 2 here. And then using the remaining ones to find the determinant. So we got 6, negative 5, 4, 1, 2, 2, and onwards. So we write it out in order. 6, negative 5, 4, 1, 2, 2, 3, negative 1, negative 1. And then plus 0 times the determinant. I'm not gonna bother writing out this determinant because 0 times any number is 0. So I'm just gonna ignore that. And just to do the 6th one now. So 6 would be plus negative 6 times the determinant of, let's do the same thing we did with 2 on this. Carefully getting rid of values which messed up. This is 3 and this was 6. So let's take the 6 and cancel the row it was in and the column. That's it. That has it. So and now we write the remaining values into the and find the determinant of them. So we had 3, 6, 3, 6, 4, 1, 1, 2, 0, 3, and negative 1. So 3, 6, 4, 1, 1, 2, 0, 3, negative 1. And again, this 0 doesn't matter because 0 times any value is still 0. And solving this out should give us our determinant. And just to make this video a little shorter, I'm not going to solve for these things. If you would like, you could do them on your own. But I have the answer for these determinants already, so I'm just going to use them. So the determinant of this one is, from what I got, negative 46. And then we got to add negative 6 times the determinant of this one here. I got is negative 6. So if you solve this out, you should get negative 56 as your answer.